Article 1.2 Permits and Inspection Certificates. 1.2.1 Electrical Permits. 1.2.1.1 Electrical permits needed before work is started before starting any installations work, alternation, repair or extensions on any electrical system. The owners, lessors, operators, occupants, or licensed electrical practitioner shall obtain electrical permits for buildings, trailers, mobile homes, or other premises from the office of the building official, and for watercrafts from the Authority for Maritime Concerns in securing the electrical permits. The services of a licensed electrical practitioner is required under the Republic Act 72920 or National Electrical Engineer Law. 1.2.1.2 Requirement for electrical permit signatures and submittals. The electrical permit shall include the following minimum informations. 1. Applicant. 2. Professional electrical engineer who signed and sealed electrical plans and specifications with photocopy of valid professional tax receipt and valid professional regulations commissions PRC license. 3. Licensed electrical practitioner who is in charge of electrical works with photocopy of valid PTR and valid PRC license. Building owner. 5. Lot owner. 6. Building official. Refer to Appendix E. 5 sets of complete electrical plans and specifications signed and sealed by professional electrical engineer. 1.2.1.3 Electrical permit to be issued immediately. The application upon receipt shall be checked immediately by the electrical engineer of the local building office of his representatives for compliance. So what this said is the article of the Philippine Electrical Code is the outlines the requirements for electrical permits and inspection certificates to ensure safe and legal electrical installations. So number 1, electrical permit requirement. No electrical work, installation, alterations, repair, or extensions may start without first securing an electrical permits from the local building official. The permit applies to all electrical systems in buildings, trailers, mobile homes, or maritime premises, ensuring compliance with National Electrical Law, Republic Act 7920. Number 2, requirements for obtaining an electrical permit. The application must include applicant's details, signatures of a professional electrical engineer (PEE) who prepared and sealed the electrical plans and specification with a valid ID, PRC license, and PTR professional tax receipt. Number 3, signature of the licensed electrical practitioners in charge of the work with valid PTR and PRC license. Number 4, building owners approval. 5, lot owners consent. 6, 5 complete sets of electrical plans signed and sealed by the PEE, referred to Appendix E. 3, permit issuance. The application is checked immediately by the electrical engineer of the local building office for compliance. Once verified, the electrical permit is issued right away. So the purpose of the permit process ensures that electrical work is designed as executed by qualified professionals inspected for safety and compliant with the PEC to prevent hazard and illegal issues. Article 1.3 Electrical Plans and Specifications. The requirements is complying, the electrical permits shall be issued upon payments of the corresponding electrical fees. If the project of is extensive and requires more time for checking of the um, routinary, fiscal, and ministerial ministerial requirements, the issuance of the electrical permits need not be issued immediately. The delay shall not be longer than 5 working days, after which time the applications together with the accompanying plans shall be considered as complying with all the requirements, and electrical permits shall be issued immediately thereafter. 1.2.1.4 Posting of the electrical permit. A copy of the electrical permit upon issuance shall be posted of the conspicuous location at the job site and shall not be removed until final inspections and approval of the work shall have been made. Licensed electrical practitioner in charge of the design and the licensed electrical practitioner in charge of the installations shall post a copy of their respective valid professional regulations commissions PRC identification card together with the electrical permits at all times. 1.2.2 Electrical inspections. 1.2.2.1 Applications for inspections and applications for inspection shall be filed with the Office of the Building Official (OBO) before a preliminary and or final inspection is done. 1.2.2.2 Certificate of inspection. No electrical installations, alterations, and or addition shall be connected or reconnected to any power supply or any other source electrical energy without a certificate of final electrical inspections computations completions obtained from the Office of the Building Official (OBO), signed by the Office of the Building Official (EE). Exemptions. A temporary certificate of the inspections may be signed by the of the building official. It's called the OBO. Exemption. A temporary certificate of the inspection may be signed by the Office of the Building Official (EE) for the purpose of testing and commissioning the installed equipment within the premises. Validity date shall be indicated in such certificate. 1.2.3 Special. 1.2.3.1 Temporary installations. For the temporary electrical installations, the same procedure as stated above shall be followed. At the end of the period covered by the certificate of inspection, the temporary installation shall be removed. Extended use of the temporary installations shall require an extension or renewal of the electrical permit from the Office of the Building Official, signed by the Office of the Building Official in EE OBO. Okay, let's proceed to second topic of my explanation. So, the electrical permit issuance. A permit is given once all requirements are met and the corresponding fees are paid. If the project needs extra time for checking or ministerial task, the permit may not be issued immediately. It will be released after the applications and plans are reviewed. Number 2, posting the permit. A copy of the electrical permits must be displayed at the job site and kept there until the final inspection is done. 3. Inspections requirements. The work must be done by a licensed electrical practitioner who signs the design. And applications for inspections must be filed with the Office of the Building Official (OBO), just called OBO, for a preliminary and or final inspections. Number 4, electrical inspections. No electrical installations can be energized until it passes inspections and gets a certificate of inspections from the OBO. A temporary certificate may be issued for testing equipment within the premises with a specified validity date. 5. Temporary electrical installation for temporary setups. The same procedures applies and permit is needed, and the installations must be removed or extended with proper renewal. In short, the regulations ensures that all electrical work is done with proper permits, inspections, and safety compliance, whether it's permanent or temporary installations. 1.2.3.4 Reconnections of disconnected services. In cases where service has been cut off for more than 1 year, a new certificate of final electrical inspections shall be required before reconnections. Article 1.3 Electrical Plans and Specifications. 1.3.1 General. 1.3.1.1 Drawing sheet size. Electrical plans and drawings shall be drawn on drawing sheets of the following standard sizes: 760 mm times 1000 mm, 600 mm times 900 mm, 500 mm times 760 mm. In cases such as projects of large magnitude, exemptions in the use of the standard drawing sheets may be granted by the office of the local building official. For a dwelling unit having a floor area of not more than 50 square meters with a total load not exceeding 3,680 VA, a drawing sheet of size 297 mm times 420 mm A3 size is permitted. 1.3.1.2 Drawing scales. Appropriate metric drawing scales shall be used. 1.3.1.3 Graphic scale. Since the size of the drawing sheets can be changed photographically, graphic scale shall be shown on each drawing sheet. FPN. Graphic scales denotes nominal or average plan scales and remains true with when plans are photographically reduced. 1.3.2 Plans are specifications. 1.3.2.1 Plans requirements. A. Locations and site plans. Location and site plans with proposed structures and owner's land drawn to appropriate metric scale shall show. 1. Bordering areas showing public of the well-known streets, landmarks, and or structures which need to not be drawn to scale unless they extend into the area concerned. 2. Locations of service drop, service equipment, and nearest pool of the utility company furnishing electrical energy. Locations of the matter of as well as sizes of service entrance wires, conduits, and service equipment. And 3. Clearance of the path or run of services drops and entrance wire to adjacent existing and or proposed structures. So I explained again the topic of our page 3. So number 1, when services are cut off and a service like electricity or water has been disconnected, a certificate of electrical installations must be obtained before the service can be reconnected. Number 2, drawing requirements. The drawings plans for the project must show the locations of all services and include details like scale 1:1000 mm or 1:500 mm and paper size A3 or A4. Number 3, approval process. The drawings need to be approved and stamped by a competent authority, and they should also indicate the maximum load in kVA and comply with standard drawing practices. Number four, inspections and safety. Before reconnecting any service, a final inspection is required to ensure compliance with safety standards and to prevent hazard like gas leaks or water damage. Documentations, number five, documentations. The specifications require that all relevant documents, plans, inspections, certificates be submitted to utility company for verifications. In short, the clause ensures that any disconnections of utilities is properly documented, inspected, and approved to maintain safety and compliance during constructions or maintenance work. 1.3.2.2 title block or nameplate of plans and drawing shall be standard strip of 40 mm high at the bottom of the sheet if shall contain shall following 1.3.3.1 shall is name and location of installations or project, name, signature, and address of owner, management, operators, title of sheet, name, signature, and seal of professional electrical engineer together with professional regulations commissions, pro- professional license number and validity, professional tax receipt number and tax identification number, scale use skate drawn and sheet number, 1.3.2.3 other details. Exposed outdoor conductors shall show means of support and types of insulators and spacings and clearances. B. Auxiliary gutters, wireways, busways, cabinets, boxes, metal raceways, underground installations other than specified in the code shall show installations details, conductors, support separators, and attachments were required by this code, and three dimensions and descriptions of specifications. C. Private pool installation shall show conduct constructions and installations details and dimensions. Two is pull tap wiring details in including line, hardware, and guying details, low energy power and low voltage and low energy power, equipment, wiring, excuse me, actuating mechanism and protective devices and ventilations details whenever necessary. So what they say in this topic is title block. Every drawing sheet must have a title block that is 40 mm high in the bottom. It should include the project title, nameplate of items, and drawing details. Plan details. Two, excuse me. Number two, plan details. The plan must show the locations and scope of the installations or project. Three, owner info. The sheets must have the name, signature, and address of the owner, manager, or operator. Reminder, this number three is the most important thing that part of the before you start to work at the building, like constructions. And four, sheets identifications. It needs a title of the sheet and a sheet number. Number five, professional stamp. The plans must be signed and stamped by a registered professional engineer or registered master electricians (RME). 6. Drawing info include the scales used and the date and the drawing was made. Exposed conductors shows where Exposed conductors will be placed insulators and clearances indicate mounting of support and types of insulators plus clearance of obstructions. So we have a lot of examples here in my uh, topic. So I can read the another, but not in necessary sentences. 10 is installations method, supports and attachments, private post installations, dimensions, feeder details, low voltage installations, and energy source. These requirements ensure that electrical plants are clear, compliant with regulations, and provide all necessary information for safe installations. 1.3.3.1 Indoor obstructions. Indoor substations plans shall show 1.3.3 substations plans and specifications, locations and dimensions, manager substations in building plans drawn to scale building with respect to entire compound or property, incoming and outgoing lines and electrical regulations validity, that Taffications, windows, doors, and other openings, substations, structural requirements, materials and constructions of walls, floors, roof, windows, enclosures, doors and their dimensions, and ventilations and drainage systems and other safeguards. Substations electrical requirements such as plan view showing locations and sizes of equipment installed and clearances and spacing between exposed current carrying and non-current carrying portions and grounding equipment and cabinets, lights, grounding system, sectional views showing horizontal and vertical clearance between exposed parts and adjacent surfaces, spacement, horizontal and vertical clearances of exposed parts from floor ceiling, and miscellaneous finished floor and ground level specifications of equipment, wiring of lighting and remote control systems, where and hardware, one line diagram of entire installations with voltage indicated power. Imputations on size of wires, bus bars, transformer, fuse, switches, and breaker and source. Class of installations is or insulators. 1.3.3.2 substations. Outdoor substations plan shall show same items as indoor substations except that is use of walls and roof details of fence and supporting steel structures shall be shown in accordance with the latest editions of the Philippine Electrical Code. Indoor substations plans must include the locations and dimensions of these substations. B. A scale drawing on the substations within the building or property showing incoming and ongoing electrical connections. C. Details of windows, doors, and other openings. D. Materials and constructions of walls, floors, roof, windows, enclosures, doors, and their sizes. E. The electrical requirements such as bus bar switches and transformer equipment installed. F. Clearances and spacing between exposed sleeve parts and grounding equipment including SLS and vents. G. Grounding systems design. H. Cross-sectional views showing horizontal and vertical clearances of exposed parts from floor ceiling. Miscellaneous details like finished floor level, ground level, and equipment specifications. G. A wiring diagram of the entire installations with voltage levels, key computations on size of items, busbars, transformer, fuses, switches, breaker, and short circuit or installations level. That's important of our topic in this our reporting. Article 1.3 Electrical Plans and Specifications. Number of phases, type and size of wiring, protective device rating, lighting and receptacle loads, panel as numbered in the figure diagram, circuits designations number, number of lighting outlets in each circuit, number of switches in each circuit, number of receptacles outlets, convenience outlets, voltage of circuit, type and size of wiring, protectives, device rating, other loads, designations, number on plan, descriptions of load, classifications of service duty, if required, rating of kilovolts, ampere, or kilowatts, phase loading indicating full load line current voltage rating, types and size of wire, protective device rating, design analysis shall be included on the drawing or shall be submitted on separated sheets. Branch circuits, sub-feeders, feeders, busways, and service entrance, types ratings, and trip settings of overload protective devices, calculations of voltage drops, calculations of short circuit current for determining the interrupting capacity of overcurrent protective device, residential, commercial, and industrial establishment, protective coordinations of overcurrent protective devices, arc flash hazard analysis to determine the required person's protective equipment, PPE, and other than FPN number 1. This analysis is not required for dwelling units but required for service equipment and other electrical equipment not part of the individual dwelling units of residential condominiums and individual detached dwelling unit. So the Article 1.3 outlines what must be included in electrical design documents, plans, and technical specifications for a project. It ensures that all electrical installations are properly documented for safety, compliance, and construction purposes. The key requirements of the list. Number one, general informations, number of phases, types and size of wiring, protective device ratings. Two, load details. Don't forget that. Separated listings of lighting and receptacle loads and other loads. Panel numbering on the fader diagram. Circuits designations numbers. 3. Circuits is specifics number of lightings outlets per circuits. Number of receptacle convenience outlet per circuit. Voltage and phase of each circuit, plans, submissions, single line diagram must be included with the drawings. Details of branch circuits, faders, buses, and service entrance. Protective devices, types, ratings, and settings of overload protections, calculations of voltage drop and short circuit currents. Safety of compliance, arc flash hazard analysis for non-residential projects, specifications of personal protective equipment PPE required, art electrical plans and specifications. FPN number 2 are flash hazard analysis. Required is intended importance of personal protective equipment PPE and its type for concerned parties to be informed and made aware of the for the flash hazards risk category determined by the analysis. Further, current protective devices coordinations coupled with flash hazard analysis can reduce the severity of PPE needed but is not required under this R flash hazard analysis. FPN number 3 IEEE is TD 15842 2002 Guide for performing our flash hazard calculations provides guidelines for our flash hazard analysis. One line diagram shall indicate one lighting and receptacle outlets loads. A single line of schematics diagram of lightings are and receptacles panel board showing means and the brand circuits rating. Size of conductors for feeder. Motor loads rating in kilowatts. Horsepower, kilovolt ampere, full load current, lock, lock motor current, phase connections for one phase motor on a three-phase system, rated voltage, type and size of wiring indicating load amperes. Electric motors shall be numbered consecutively to correspond to their numbers in the layout. Faders of sub-faders, identifications and or labeling of faders and sub-faders, size and type of wires and raceway, protective devices and controls, the allowable capacity of the doctor over the design's load current in amperes expressed as a ratio and indicated alongside the conductor. Load center identifications and or labeling of load center, showing type and rating transformer switches in becoming and outgoing feeders, type, size and voltage, equipment and grounding. So okay, number one, arc flash hazard analysis, a study that identifies the risk of electrical arcs, dangerous energy releases, and determines the necessary personal protective equipment and safety measures. IEEE STD 1584 2002 is a standard that gives guidelines for performing arc flash calculations, helping engineers assess the energy levels and protections needed. 3. The one line diagram, single line diagram is a simplified schematic that shows the electrical distributions system, mains, panel, circuits. It must include specific details like lighting and receptacle loads, a separate line for each type of load, motor loads, size of conductors, full load current, lock motor, rotor current, etc. Phase connections, how a single phase motor connects to three-phase system, wiring, type, size, and ampacity of conductors, faders and sub-faders, identifications, labeling, and sizing, protective devices, ampacity, and settings, load center transformer, data switch ratings, incoming, outgoing faders, and grounding. In short, the documents sets the standards and creating electrical plans that ensure safety, arc flash analysis, and proper system designs, one-line diagrams with detailed load and equipment informations. Article 1.10, Requirements for Electrical Installations. 1.10.1 General. 1.10.1.1 Scope. This article covers general requirements for the examinations and approval, installations and use, access to and spaces about electrical conductors and equipment, enclosures intended for personnel entry and tunnel installations. 1.10.1.2 Approval. The conductors and equipment required or permitted by this code shall be acceptable only if approved. If PNC 1.01.1.7 Examinations of equipment for safety, and 1.10.1.3 Examinations, identifications, installations, and use equipment. See definitions of approved. Identify labeled and listed installations and use with equipment, definition for approved, and 1.10.1.3 Examinations, identifications, installations, use, and listing product certifications of equipment. Examinations in judging equipment considerations such as the following shall be evaluated: suitability for installations and use in conformity with the provisions of this code. FPN number 2, suitability of the equipment's use, may identify descriptions, mark on, or provide with approved identification suitable for products, specific purpose, environment, and applications. Suitability of equipment may be evidenced by listing or labeling. Mechanical strength and durability, including for parts designed to enclose and protect other equipment, the adequacy of the protections thus provided. Wire bending and connection space, electrical insulations, heating effects under normal conditions of use and also under abnormal conditions like to arise in service. Arcing effects, classifications of type size, voltage, current, capacity, and specific use. Other factors that contribute to the practical safeguarding of persons using are likely to come in contact with the equipment. Installations and use listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing of labeling. Listing product testing evaluations and listing product certifications shall be performed by recognized qualified electrical testing laborers. General scope. This article lays out the basic rules for examining, proving, installing, and maintaining electrical equipment and wiring spaces where people can enter or internal installations. Approval. All electrical conductors and equipment must be improved, tested, and certified for their intended use. Only approved items are allowed by the code. Equipment examinations. When judging if equipment is acceptable, inspectors evaluate factors like suitability, mechanical strength, on durability, wiring and connections, safe wiring practice and required. Electrical installations, heating effects, it must handle normal and fault conditions without overheating. Arcing equipment must manage arcing risk. Classifications device are rated by type, voltage, current, and use. Installation and use. Equipment but must be installed according to its listing or labeling. And testing products must be certified by recognized testing labs. Key terms: approve, identified, mark, and specifications or descriptions. Labeled, listed, is certified by a testing authority. In short, this article ensures that all electrical installations are safe, properly certified, and installed according to standard of the won't cause electrical hazards or failures. Recognized as achieving equivalent and effective safety in accordance with applicable products, standards, and equipment installed for compliant with this code. OSHA recognizes qualified electrical testing laborers that FPN, the Occupational Safety and Health Administrations, perform evaluations, testing, and certifications of certain products to ensure that they meet the requirements of both the constructions and general industry. OSHA electrical standards in the listing laboratory program. This listing mark signifies that the tested and product certifications is done under a qualified electrical testing certified product complies with the requirements of one or more appropriate product safety and test standards. 1.10.1.4 voltages throughout this code. The voltage considered that shall be that at which the circuits operates. The voltage rating of electrical equipment shall not be less than the nominal voltage of a circuit to which is in connected. 1.10.1.5 conductors normally used to carry current shall be of copper or aluminum unless otherwise provided in this code. Where the conductor material is not specified and the sizes given is this code shall apply to copper conductors. Where other materials are used, the size shall be changed accordingly. FPN the for copper clad aluminum conductors C 3.10.1.15 1.10.1.6 conductor sizes are expressed in metric system like is the one from grounds other than the required or permitted in Article 2.50 1.10.1.8 wiring methods. Only wiring methods recognized as suitable are included in this building or occupancy, except as otherwise provided in this code. 1.10.1.9 interrupting rating equipment intended to interrupting current and at fault levels shall have an interrupting rating at nominal circuit voltage at least equal to the current that must be interrupted. 1.10.1.10 circuit impedance, short circuit current ratings, and the other characteristics. The ratings and other characteristics of the circuits to be protected shall be selected and coordinate for to permit to the circuit's protective devices used to clear a fault to do so without extensive damage. National Electrical Code. It covers several key sections related to electrical safety standards and requirements. Here's a simplified explanation of the main points. One, safety and testing. The code recognizes laborers that test and certify electrical products to ensure they meet safety standards. Products must comply with specific safety test standards to be deemed safe for use. Two, voltage considerations. And three, conductors. For wiring identifications, wiring installations must be free from short circuits and grounded properly. The, the code lists approved methods as types of wiring. And interrupting rating, the equipment intended interrupting fault and the current like current breakers must have an interrupting rating at least equal to the available fault current and its terminal. 6 is short circuit current ratings. Protective devices must have appropriate impedance and short circuit current rating to safely clear faults without excessive damage. In short, the test outlines safety requirements for electrical equipment, conductor selections, wiring practice, and protective devices to prevent electrical hazard and ensure compliance with testing standard. To the electrical equipment of the circuits, this fault shall be assumed to be there either between two or more of the circuit's conductors and between any circuit's conductor and the equipment grounding conductors. Permitted in 2.50.6.9, listed equipment applied in accordance with their listing shall be considered to meet the requirements of these sections. 1.10.1.11 Data ratings agents unless identified for use in the operating environment. No conductors or equipment shall be located in them or wet locations. Where exposed to gases, fumes, vapors, liquids, or other agents shall that have a deteriorating effect on the conductors and equipment, or were exposed to excessive temperatures. FPN number 1, C 3.0.1.6 for protections against corrosions. FPN number 2, some cleaning and lubricating compounds can cause severe deteriorations of many plastic materials used for insulating and structural applications in equipment against permanent damage from the weather during buildings constructions. FPN number 3, C table 1.10.2.3 for appropriate enclosures type designations. FPN number 4, minimum flood provisions are provided in NFPA 5000 2015 Building Constructions and Safety Code. The International Building Code (IBC) and the International Residential Code for 1 and 2 Family Dwelling IRC 1.10.1.12 listed and labeled when not required. Electrical equipment, materials, and services shall not be required to be listed and or labeled when local or international products and services standards do not require listing and or labeling. 1.10.1.13 Mechanical executions of work. Electrical equipment shall be installed in neat and workmanlike manner. FPN accepted industry practices and described and ANSI NICA 1 to 2015 Standard for Good Workmanship and Electrical Contracting and other ANSI approved installation standards and use openings other than those intended for the operations of equipment, those intended to mounting purpose, or doors permitted as part of the design for listed equipment shall be closed to afford protection substantially equivalent to the wall of the equipment. Where metallic plugs or plates are used with non-metallic enclosures, they shall be recessed at least 6 mm from the outer surface of the enclosures. Integrity of electrical equipment and connections. Internal parts of electrical equipments, including bus bars, wiring terminals, insulators, and other in surface shall not be damaged or contaminated. Requirements for electrical installations from an electrical code document. Here's a plain breakdown for the main points of sections or my highlights. Number one, the deteriorating agents. Electrical equipments must be protected from things that can cause and self-degrade, like moisture, chemicals, or excessive heat. If the environment is harsh from gear has to rated for those conditions or shielded. Number two, protections from weather. Equipment use outdoors and wet locations needs to enclosures ratings that must be the exposure. See table 1.10.2 to 3 for specific disclosures types. Three minimum provisions of fixtures installations must follow the latest versions of NFPA 5000 Building Constructions and Safety Code and the International Residential Code RIC for proper fixtures and supply requirements. For listing and labeling, equipment must be listed and labeled by a recognized testing agency unless a specific product standard says otherwise. Listed means it's been tested and approved for its extended use. Mechanical executions of work. Electrical work should be done neatly and follow good workmanship practice. This includes sealing unused openings and closures and keeping internal parts, busbar terminals, insulators free, damage of contaminations. Short the article sets rules for installations electrical equipment so it stays safe and functional by protecting it from environmental damage, using proper enclosures, following listing requirements, and maintaining goods workmanship. By foreign materials such as paint, plaster, cleaners, abrasives, or corrosives residues, there shall be no damaged parts that may adversely affect safe operations of mechanical strength and the equipment such as parts that are broken, bent, cut, or deteriorated by corrosions, chemical actions, or overheating. 1.10.1.14 Mounting and cooling of equipment. A mounting electrical equipment shall be firmly secured to surface on which it is mounted. Wooden plugs driven in holes and masonry, concrete, plaster, or similar material shall not be used. Cooling electrical equipment that depends on the natural circulations of air and convection's principles for cooling of exposed surface shall be installed so that room airflow uh, over such surfaces is not prevented by walls or by adjacent installed equipment and for equipment designed for floor mounting. Clearance between top surface and adjacent surfaces shall be provided to uh, dissipate rising warm air. Electrical equipment provided with ventilating openings shall be installed so that walls or other obstructions do not prevent the free circulations of air through the equipment. 1.10.1.15 electrical connections. Because of the different characteristics of the similar metals devices such as pressure terminal or pressure splicing connectors and soldering lugs shall be identified for the material of the conductor and shall be properly installed and used. Conductors and dissimilar metals shall not be intermixed in a metal or splicing connector where physical contact occurs between dissimilar conductors such as good copper and aluminum, copper and copper clad aluminum, or aluminum and copper clad aluminum, unless the device of identified for the purpose and conditions of use. Materials such as solder, fluxes, inhibitors, and compounds where employed shall be suitable for the use and shall be of a type shall that will not adversely affect the conductors and solutions and equipment. Connectors and terminals for conductors more finely stranded that Class B and Class C stranding is shown is copper 10, table 10.1.1.10 shall be identified for the specific conductors class or classes. Terminals, connections, and conductors and terminal parts shall ensure the thoroughly good connections without damaging the conductors and shall be made by means of pressures connectors including set screws type, solder lugs and splices, and flexible leads connections by means of wire binding screws and studs nuts that have upturned lugs or the equivalent shall be permitted for 5.5 mm to 2.6 mm diameter or smaller conductors. Electrical installations focusing on safety and proper setup of electrical equipment. Number one, general conditions. Electrical gear must be free of foreign materials, paint, plaster, cleaners, etc., and have no damaged parts that could affect safety and performance due to corrosions, chemicals, or overheating. Number two, mounting 1.10.1.4 equipment should not be firmly secured to surface, masonry, concrete, plaster. Using appropriate fastener and wooden plugs are not allowed. They have another example for these explanations. Number three, cooling. Devices that need natural air circulations must not have their air intake blocked by the walls of their objects. These should be placed to allow free airflow and dissipate heat properly, preferably near top surfaces or for ventilations. Installations near walls, equipments with ventilation openings should be installed away from walls and fractions to ensure air can flow freely through the equipment. Number five, the electrical connections involving the similar metals to aluminum and copper must avoid direct contact to prevent corrosions. Use suitable intermediate materials to the proper splicing devices. Terminal for conducts and ensure solid pressures to connections. Terminology. Conductors are classified into Class B, Class C, based on standing as shown as Chapter 10. In short, the roles of electrical equipment installed circularly kept clean as good ventilations. Terminals for more than one conductors and terminals used to connect aluminum shall be so identified. Splices conductors shall be spliced or joined with splicing devices identified for the use whether by brazing, welding, or soldering with the suitable metal or alloy. Soldered splice shall be first put spliced or joined so as to mechanically, electrically secured without solder on and then be desoldered. All splices and joints and the free ends of conductors shall be covered with the insulations equivalent to that the conductors or with an identified insulating devices. Wire connectors or splicing means install the conductors for direct burial shall be listed for such use. Temperatures, limitations for the temperatures rating, insulations with the ampacity of the rating of the connected terminations conductor or device conductors with temperatures ratings higher than specified determinations shall be permitted to be used for ampacity adjustments corrections or both. Equipment provisions, determinations for determinations provisions of equipment shall be based on 1.10.1.14 or unless the equipment is listed and marked. Otherwise, conductor capacities used for determining equipment determinations provisions shall be based on the table 3.10.2.6 as appropriately modified by 3.10.2.6. At termination provisions of equipments for circuits rated 100 ampere or less are marked for 2.0 mm 1.6 mm diameter through 38 mm conductors shall be used only for one of the following conductors rated 60 degrees Celsius. Conductors with higher temperature ratings provided the opacity of such conductors is determined based on the 40 degrees Celsius ampacity of the conductor size used. Conductors with higher temperature ratings of the equipment is listed and identified for use with such conductors. For motors marked designs letter B, C, or D is conductors having insulations ratings of 75 degrees Celsius or higher shall be permitted to use provided ampacity or such conductors does not exceed it for the 75 degrees Celsius. Ampacity terminations for provisions of equipment for circuits rated over 100 ampere or marked for conductors larger than 38 mm shall be used only for one of the following. Terminals for multiple conductors. Terminals for more than one conductor or for aluminum connections must be clearly identified for the specific use. Two is splicing conductors. Conductors are joined using approved splicing devices like welding, bracing, and soldering with a fusible metal alloy. The splice must be mechanically and electrically secured and soldered with isolated for the match conductor solutions. Wire connectors, temperature limitations is the temperature's rating of the conductor must exceeded for lowest temperature rating of any connected component. Higher rated combinations can be used if the equipment allows it. Terminations provisions, equipment terminations rules are based of the 60 degrees Celsius ampacity used unless the equipment is marked for 70 uh, degrees Celsius or higher. For circuits, 100 ampere is 60 degrees Celsius rated conductors are used for 100 ampere. 75 degrees Celsius rated conductors can be used. For conductors is 38 squared. The termination is limited to specific conditions. So, in short, the article of sets standards for safety joining and terminating. Conductors ensuring the connections are mechanically strong, electrically sound, and rated appropriately for temperatures and ampacity. Requirements for electrical installations. Number one, conductors rated 75 degrees Celsius, provided the ampacity of such conductors does not do conductors with higher temperature ratings exceeded for 75 degrees Celsius ampacity of the conductor size used, or up to their ampacity if the equipment of listed and identified for use with such conductors. Two is separated connector provisions. Separately installed pressure connectors shall be used with conductors of the ampacities not exceeding the ampacity at the listed and identified temperature rating of the connector. FPN with respect to 1.10.1.14 say A and say 1 say 2 equipment markings for related informations may be actually strictly emphasizing temperature ratings of connected conductors. Installation where listening torque is indicated as a numeric value of the equipment of the installations structures prohibited by manufacturer. A calibrate torque tool shall be used for achievement indicated torque value unless the equipment manufacturer has provided installation instructions for an alternative method of achieving and requires torque. 1.10.1.16 is high leg marking on a four-wire delta connection system where the midpoint of one phase windings is grounded. Only the conductor as busbar having the higher phase orange in color or by other effective means such identification shall be placed as each point on the system where a connection is made in a grounded conductor is also present. 1.10.1.17 is arc flash hazard warning. General installation electrical equipment such as switchboard, switchgear, panel boards, industrial control panels, metal sockets enclosure, and motor control in centers that is other than dwelling units is likely to require examinations, adjustments, servicing, or maintenance while flash hazard under the marking shall meet the requirements in 1.10.1.21b and shall be located so as to declare receivable qualified persons before examinations, adjustments, servicing, or maintenance of the equipment. Service equipments in others than dwelling units are additional to the requirements in ampere and permanent label shall be filled or factory applied to services equipment rated to 1000 ampere 1200 ampere or more. The labels shall meet the requirements of 1.10.1.21b and contain the following informations. So nominal system voltage. 75 degrees Celsius conductors rated for 75 degrees Celsius are allowed, but their ampacity is current carrying capacity must not be exceeded. Higher temperature conductors can be used at their normal capacity only in equipment of listed and identified for such use. Two is separated connectors provisions and pressures connectors like must be installed separately from capacity limited conductors. Three is FPN fine print note equipment markings then size copper aluminum may limit the size of temperature of connected conductors. Before is tightening torque. So a specific torque value listening tightening force must be applied when installing connectors unless equipment provides its own constructions or alternative methods. 5 is the high leg marking in the four-wire delta system with a high leg orange phase. The high leg conductor must be marked with orange of another specific effective means at each point of connections. Arc flash hazard warning. 7. Service equipment. 8 is nominal system voltage. The system voltage rating must be identified and comply with additional requirements listed in sections 1.10.2.21b. The section sets rules for safely installing and rating electrical conductors and equipments, focusing on temperature limits, proper connections, torque settings, labeling, and safety warning for arc flash high leg system. Article 1.10 Requirements of the electrical installations. Available fault current is service over current protective devices. The clearance time of service over current protective devices based on the available fault current at the service equipment. The date the label was applied. Exemption service equipment label shall not be required in arc flash label and is applied in accordance with acceptable industry practice. FPN number 1 NFPA 70E 2015 It is standard for electrical safety in the workplace provides guidance such as determining severity of potential exposure, planning safe work practice are flush labeling, and selecting personal protective equipment. FPN number 2 in C is the 7535 42 2011 Product Safety Signs and Labels provides guidelines for the designs of safety signs and labels and applications to products. FPN number 3 acceptable industry practice for equipment and labeling and described in NFPA 708 2015 Standard of Electrical Safety in a Workplace. This standard provides specific criteria for developing arc flash labels for equipment that provides a nominal system voltage incidence energy levels are flash boundaries minimum required level of personal protective equipment and so forth. 1.10.1.18 are some parts of electrical equipment that in ordinary operations produce arc sparks, flames, or molten and metal shall be in enclosed or separated and isolated from all combustionate material flames. So no materials in the FPN for hazard classified locations and articles 5.0 through 5.17 for motors. C for 4.30.1415 is connection to system contains truly and with a ground return. Exemptions as circuits connections shall be permitted in car houses, powerhouses, and passengers and freight stations operated in connections with electric always railways. So 1.10.1.21 marking equipment markings general the manufacturer's name, trademark, or other descriptive marking by which the organization responsible for the product can be identified shall be placed in all electrical equipment. Other marking that indicate voltage, currents, watts, or other rating shall be provided to specified environment involved. Reconditioned equipment shall be marked with the name, trademark, or other descriptions marking by which organizations responsible is reconnectioning the electrical equipment can be identified alone. So, here's simplified explanations of my main points in plain. So, number one, protective devices. Electrical equipment must be protective device like fuses and circuit breakers, rated for the available fault current and the service locations. Number two, clearing time. That time it takes for these protective devices to shut off and fault sound should be based on available fault current and protective equipment. Three, labeling equipment needs a label showing it means safety standard unless an arc flash label is already applied. Before applicable standards, the code referenceable standards in FPA 70E, ESTM F1506, and FEPA 70 that give rules for safety in a workplace, including personal protective equipments and labeling markings electrical equipment must have markings like a manufacturer's name or inform about its intended use. Six is reconditional equipment. If equipment is rebuilt, it should be marked with a reconditioner name and details so it can be traced. And in short, the Article 110 sets the safety requirements of electrical installations, proper protective devices, correct labeling, and compliance with safety standards to ensure equipment is safe and identifiable. With the date of the reconditioning, reconditioned equipment shall be identified of reconditions and approval of the reconditioned equipment shall not be based solely on the equipment original listening. Exemptions is industrial occupancies where conditions of the maintenance of supervisions ensure that only qualified persons services equipment that markings indicated in 1.10.1.21a shall not be required. If PN industry standard are available for applications of recognitions, reconditions, and refurbish and equipment normal servicing of equipment that remains within a facility should not be considered reconditioning and refurbishing. Field applied hazard markings where cautions, warning, or danger signs or label are required by this code and label shall meet in the following requirements. The markings shall warn of the hazard using effective words, colors, symbols, or any combinations thereof. If PN and C 5354 2011 Product Safety Signs and Labels provides guidelines and for suitable font size words, color symbols, and locations requirements for labels. The labels shall be permanently affixed to the equipment or wiring methods and shall not be handwritten. Exemptions to port portions, labels, and markings that are variable or that could be subject to changes shall be permitted to be handwritten and shall be legible. The label shall be sufficient durable for withstand its environment involved. If PNNC for at 535.4 for 2011 products is as six science products guidelines and designs and durable safety and labels and applications for the premise. 1.10.1.22 Identification disconnecting means general is the connection means shall be eligibly marked for the intended purpose unless located and arranged to the purpose is evident. The marking shall be of sufficient durability to withstand and the environment involved. Engineered series combinations for a system equipment enclosures for equipment breaker or fuses applied in compliance with series combinations ratings are selected under engineering supervisions in accordance with 2.40.7.7a shall be eligibly marked in the field as directed by the engineer to indicated of equipment has been applied with a series combinations rating and marking shall meet the requirements in 1.10.1.21b and shall be readily visible and state in the following. So the explanations is one is reconditions equipment. Any equipment that has been reconditions must be clearly marked, reconditions and approved. So number two is labeling requirements. Labels must warn about hazard using proper wording, colors, or symbols. Labels should be durable and permanently attached. They can be handwritten only if writing will stay illegible. Three is identifications of disconnecting means switches or devices that disconnect power should be clearly marked to show their purpose unless the intent of abuse from their design. Before is engineered series combinations, system enclosures for circuit breakers or fuses must have markings that comply with specific engineering standards and remain visible for inspections. The document sets safety and labeling rules for the conditions, electrical gear, and related installations to ensure proper identifications and hazard warning. Series combination system rated amperes identified replacement components required. Tested series combination system equipments enclosures for circuit breakers of fuses applied compliance with the series combinations rating mark on the equipment by the manufacturer in accordance with 2.40.7.7 shall be legibly marked in the field to indicate the equipment has been applied with a series combinations rating. The marking shall meet the requirements in 1.10.1.21b and shall be readily visible and state with the following. Question: series combination system rated amperes to identifications replacement components required. If FPN C IEEE is 3004 5 to 2014 recommended practice of the applications of low voltage circuit breakers in industrial and commercial power system for further information for series tested systems. 1.10.1.23 current transformer and unused current transformers associated with the potentials energized circuits shall be short circuits. 1.10.1.24 available fault current field marking service equipment of the other than dwelling units shall be legibly marked in the field with the maximum available fault circuit with a field marking shall include the date the fault current its calculations must perform and be conservation's durability with wasted and environment involved and calculations shall be documented made available to those authorized to design, install, inspect, maintain, or operate the system. If PN, the available fault current markings addressing in 1.10.1.24 is related to required short circuit current ratings and equipment in FPA 708 to 2015 standard for electrical safety in the workplace provide assistance in determining the severity of potential exposures, planning safe works practice, and selecting personal protective equipment. At the service, a maximum available fault current shall be yet filled or recollected as necessary to ensure the service equipment ratings are sufficient for the maximums available fault current at the terminals of the equipment shall the equipment and equipment sufficient for the maximums available fault current and the terminal of the equipment the exemptions and field marking requirements for the 1.10.1.24 is shall not be required in industrial installations where conditions and maintenance and supervision ensure that only qualified persons service the equipment. So, series combination system equipment must be listed and identified for use with a series combinations rating. The system has a specific ampere ratings and requires replacement components that are identified and compatible and two is fault current making marking service equipment like breakers or fuses must be marked with the maximum available fault current and can handle. Three is available fault current. The available fault current is the maximum short circuit current the system can deliver at a given point. This value can be determined usually through the calculations of testing to ensure protective devices can interrupt the fault safely. Modifications: if you change the electrical installations, etc., and add equipment, you must be re-evaluate the maximum available fault current and update marking it needed. Reference standards: the next reverse NFPA 70A Electrical Safety in the Workplace and IEEE is 1584 Guide for the for fault current escalations. We provide details practice for the installations and maintenance. The article ensures electrical systems are designed and marked proper to handle fault current and safely requiring proper labeling, qualified maintenance, and compliance with specific testing hazards. Okay, the last page of my presentations of reporting and electrical technology. Requirements for electrical installations is 1.10.1.25. Lockable disconnecting means if disconnecting means is required to be shall be capable for of being locked in the open positions supervisions or locking shall remain in a place with or without the lock installed. Exceptions: locking provisions for a cord and plug connections shall not be required to remain in place without the lock installed. Number one, this is my last explanation of my presentations. So number one is the lockable disconnecting means is if a disconnect switch or any disconnecting means is required by the code To be lockable, it must be capable for being locked in the often positions. The locking mechanism that hardware that hold the switch lock must be installed on the device whether lock itself is actually used or not. Two exemptions for cord and plug connections, like a plug you insert into an outlet. You don't need to provide a locking provisions. The plug can stay in place without a lock. Simple explanations, electrical setup, and any switch that needs to be lockable must have a way to lock it open. It to prevent accidental power on. The lock hardware should be installed even if you don't always use a lock. The rule doesn't apply to ordinary plugs.